I'm Dave Stokes. I am the community manager at dbeaver. We're a universal database tool. I have one slide about at the very end to help my bosses be happy with me. We're talking today about SQL window functions, and I'm going to try to teach them to you in 5 easy steps. This is a subject that could take you years to master, so I'm just going to give you the 10,000-foot overview. And by the way, if you want the slides, I'll repeat this later. It's out there at slideshare.net/David M. Stokes. And if you have questions, pop them up in the chat, and I will peek at them as I can. So, structured query language window functions are a tool for data analytics. If you're used to spreadsheets, you're probably going to go, oh, this isn't very great. But for databases, this is amazing stuff. It lets you get to a better level than just a plain group by. Now, I'm going to tell you the syntax is obtuse. The verbiage is a little bit unregular. You'll hear things like unbounded previous and unbounded later. Don't worry about that right now. I'm just trying to get the overview of this. And once again, this is a quick introduction. This is a great way to learn more about your data, but it does take some practice to get used to it. So, big revelation for me, and probably for a lot of you out there who are really good data heads, structured query language is not everyone's favorite. That's kind of a shock. I was kind of flabbergasted when I found out there's other things out there that people prefer, but SQL is out there and it has some interesting features. Now, one thing about SQL is it's been around since the 1970s because of its power and the way it works with data. The relational model is fantastic for storing and retrieving data. It fits a lot of business models. It's not a panacea for everything, but SQL has been around for a long time and other things have faded away. Now, Willamette has a query syntax, quirky syntax, that's a little bit odd. And then when you put transactions around it, it gets kind of weirder still, but it works really well. And one of the things I got to warn you, SQL tends to give back exactly what you asked from it. So like a bad AI, if you ask something a little obtuse, it will give you something back obtuse. So analytics and SQL by themselves can be frustrating. There are a limited number of aggregate functions, the built-in ones like sum, average, few databases have mean, medium, mode, that sort of thing. They're there, but they're limited. And when you're trying to do that with a group of data, the groups aren't usually granular enough to give you the control that you want or the insights that you want. So what does a window function do? Why are they here? Well, once again, they give granular insights that beyond what a group by can do. The syntax, once again, is a little weird, but with practice, and some clear examples, you'll get really good at it. Now, if you want to practice this at home and you're running Postgres, download the DVD rental data set that's been out there for a long time, and it is great for practicing on, has a lot of transactions to work through. In the MySQL MariaDB world, work with the Sequela or the World database. These things are very well known, easy to get to. If you blow them up, you can download them again, start again. They also let you gain insights to the data. And also there are a ton of documentation on blogs, tutorials, videos out there on the internet. My friend Bruce Momgen has one for the Postgres world. So if this doesn't go deep enough, you're lucky in that there's a ton of other material out there. Now, these window functions perform calculations against a set of row or a window. Pretend like you have like a little letterbox view of something on a piece of paper. The stuff up above and the stuff below you can't see, but you see the stuff that's in the open space. And window functions can let you stay with individual rows while calculating values. The basic syntax is the function like sum, average, over a partition. And this is how you're going to define your data. That's the basic thing. So the keyword you want to look for is over. So you're going to see the way how we do some analytics and some ranking with that. And in comparison to group by reduces the number of rows while window functions preserve them. Group by tends to homologate too much, where the window functions give you the insight to what you want. Example, calculate the total sales per region versus calculating the sales contribution of each order to a region's total. It's a lot more fine-tuned. Visual representation, if you're using an aggregate function in SQL, you're going to have all these things grouped by and get a sum of all these. With a window function, you're going to get a sum of the green, a sum of the lemon, and a sum of the periwinkle. So it gives you, once again, that insight that helps. Now, here's our first example. We have a simple query. It's a select statement. We're going to ask for employee ID, department, salary from employees. Now, this here is probably the thing that looks a little weird to you if you're not used to windowing functions. And it says what we're going to do is we're going to take the salary column and we're going to sum it up. But we're going to look at it by each department. And we're going to call each department's sum of the salary total department salary. This is about as easy as it gets. And once again, we're getting the department total salary here. It's fairly straightforward, works easily, works very well. And once again, the trick here is realize that we're doing this action over this part of data. Now, the syntax, and this is the syntax page from Postgres 18 that was released about a month ago. You're going to see a window function with an argument, and then once again, the over clause. And then you can partition. You can also do an order by within that, ascending, descending, using an operator. You can say how you're going to handle nulls and things like that. And the frame clause that we won't have time to go over today because we're limited on time. But this is the basic syntax. And once again, the keyword is over. So in this example here, like you've seen earlier, we're selecting employee ID, department salary, and then we're going to rank over the department by the salary descending. So you're getting the highest paid person in each department first as rank and department. And we're also doing a sum of the salary by the department on the salary. And we're saying that the rows between unbounded, preceding, and current row. We'll talk about that a little bit as running total salary. So this will print out each department, starting with the highest person in that department, and then the sum of the salaries as you go down. So if Joe's getting $10 in that department and Mary's getting $9, and it's going to stack down that way, and you'll get a running total of 19 off on the other side. So the functions, depending on what database you're using, you might have more or a lot less than this. There's great ones for aggregates, doing sums, average, count. You can do ranking, where it will give you a rank, a dense rank. It will even generate row numbers for you. So if you want a row number for the number of people in the department, you can have that unique for the department. Now, the over clause defines the window. The window, once again, is that little slit that we're looking through for the data that we can see, not the stuff above or below. Now, partitioning is how you pick what you're going to look at. Department, vendor, order date, any sort of data you can have in there, you can use some sort of partitioning on. Now, order by default, it's going to be ascending. If you want descending, you'll have to specify that. And frame specification. This is where it gets a little hairy because you're going to start seeing some odd definitions. This one says rows between unbounded preceding and current row. What that says is I'm on a certain line in a table, and I want to see everything that came. I want to add up everything, or I want to average everything that came between this current row that I'm on and the top row. So unbounded preceding is the top, and unbounded, as you'll see later at the bottom, gets you from where you are to the bottom. So let's talk about that. Unbounded preceding. If we're over here on this row, and this is the row we're cranking through, or we're trying to do calculations, we can go back and do n rows. So we do like a 3-day moving average before or like a 3-day average behind. And then you can say number proceeding. So if you wanted, well, that's the end rows. And then you have unbounded proceeding, which is the beginning of the partition of the data that you have, and unbounded following, which is the end of the partition. This is the toughest concept in all of window functions. If you remember that you have the current row, you can go back X number of rows, or in this case, N or M, or you can go back through the entire partition from the beginning to the end. Okay, so let's work up a running total of sales within each year ordered by the order date. So we're asking the database for the order ID, the order date, and the sales from the order table. And we're asking it to sum the sales, and we're going to ask it to partition by the year. We're using this function here to take the year from the order date, which is probably a month, day, year. So we're just having the year right here. We're going to order these orders by that order date, what we're doing here. And we want to know what the values are between the unbounded preceding and the current row. So from the beginning of the data that we have until the current row as a running total. Once again, this is doing a running total. So from the first entry we have to where we are right now, we're summing up all we're getting. Okay, once again, average functions will depend on what database you're using. Once again, you have some average, count, max, min, that sort of thing. Ranking functions, row number, rank, dense rank, entile. If you want a quartile, you do the entile starting with 4. What's interesting is if you haven't seen rank and dense rank, one of them, if you have people who have ties, the first one that shows up gets the rank. If you have a dense rank and you have 2 people tied at the silver medal, some would say, they will show up as the silver medal instead of having a sequential number. There are functions for lag and lead. So if you're doing moving averages, that is what you're going to use. You can also ask, hey, between the first value or the last value or the nth value and what I have now, do a calculation. So if you're doing a running total for your department, you can compare what your current line is to the top line in that data. You may have cumulative distributions, percent ranks, percentiles, all these other great functions. And once again, I can't really go into that because I'm limited on time. Now, something that might come in handy, here we're looking at grabbing the employee ID, the department, the salary, and we want to rank all the departments, and we want to order the people in that department by salary descending. So it's going to have the highest paid, second highest paid to the nth highest paid. Very simple. If you understand this, you are 90% of the way there to mastering windowing functions. Now, if we want to do something a little more precise, we can track cumulative sales per customer over time. So what we're going to do is we're going to sum up the sales for each customer, the partition by customer ID. That's our partition. So we're going to look at customer level, so like number 42. We're going to order all those by the order date, which again is going to be ascending. And we want to do a running total between the first record that we have and the current row. So if they have 5 orders for 100, 90, and 80, you're going to see 100, 190, and then 270. Here's one we're going to look at the previous sale for each customer, useful for calculating the differences. So if your boss wants to know if your customers are buying more or less, you'll be able to track that. What we're going to do in this case is we're going to lag the sale. That means kind of hold back a little bit. And what we're lagging on is the previous sale. So we're going to look at the previous sale and this sale, and we're going to get a value of how it's going up or down. Okay, challenges and pitfalls. Once again, you've seen that this is some crazy syntax like the unbounded preceding and following. When you start working this, you are going to make mistakes. Don't worry about it. You kind of have to be careful on what you're framing. Make sure that you double check your numbers. If you forget an order by and running totals, you'll get the entire partition. So if you see the entire partition, that's probably what your problem is. The solution there is always put in an order by. So order by rows between unbounded preceding and the current row. Performance issues. Large partitions are poorly defined windows can slow queries. If you want to break down by every customer, by country, or by city, that's going to be a lot easier than doing it by the entire planet. So make sure you're scaling your query uh, the way you want. Also, you need to understand the difference between a rank and a dense rank, or a row versus range. If I'm looking for a range of the five previous rows and the five following rows, that may not be what I want. So make sure that you do some hand calculations, pencil and paper. Make sure you're getting what you want. Once again, the syntax is obtuse. SQL standard is a wonderful thing. The bad trouble is the implementations aren't there. And sometimes when things are chosen by committee, they're not always the easiest thing to comprehend why they made their choices. So I meant the rows between one preceding and one following is hard to parse mentally. Yeah, you got three rows, but you got to make sure that you understand that you're looking at the one before and the one after. Sometimes it helps to break down the queries into smaller parts, and I really like using CTEs to do that. Some best practices: start with simple windows, partition by without an order by, and build complexity. When you're doing this, use meaningful aliases. Use running total, don't use the default sum, or don't do as sum. The two reasons for this is it's clearer for someone else reading it, and the second reason is because 6 months when you come back to this query and you don't know what it's doing, it helps you leave yourself clues. Also, if you're having trouble with performance and you know how to run, explain, analyze, make sure that you have things set up properly on your system and that the indexes are there and everything else you need. Also, before you tackle that data warehouse or that data lake, visualize the window with small data sets to confirm your logic to make sure it's there. You don't want to churn something for hours and hours and hours and find out that you have something that you assumed that is wrong. Once again, indexes can help. Here we're creating an index on orders and customer date. So we're taking the order table and creating an index on those two columns. And when we run select, of course, the customer ID is going to possibly be used for an index. And also down here in the where clause, the order date, depending on your database, that might picked up. But the idea here is that indexes can speed things up for you greatly. Once again, this depends on your database and the release of it. Okay, last thing, or next to last thing, practice, practice, practice. SQL is a skill like learning how to play the piano or guitar or driving a stick shift. To be good at it, you have to do it, and you have to understand how it works, and you have to be the equivalent of the muscle memory has to fit in there. You need to work with them, and competency comes from a lot of repetition. The old thing that it takes 10,000 hours to get to do something, well, that's kind of being a lot of psychologists say, well, maybe it's not 10,000 hours to do something, it's just 10,000 iterations. Hopefully it won't take you that long to get the basics, but make sure you practice. Go out to those data sets I mentioned earlier, make up some stuff, try to find out your best customer or the best cities. What are the most popular items? What's going on? Now, when you know you're getting good, you'll be able to look at this and say, aha, I know exactly what this is doing. So this is a little more complex than what you're used to seeing so far in this thing. We're going to average the sales, and we're going to do it by month. We're going to take the month from the order date, and we're going to order it by the order date. And we want to know what were the two things or the two values in sales that they had before the current sale. So if they're buying something piecemeal, they bought the tires for your car, they bought the engine, and now they're buying the chassis, you can probably get a clue that they're going to buy the interior or the gas tank or something like that if they're dealing with automobiles. So start playing with these things and make sure you practice a lot. Now, here's something interesting. We're going to lag sales by month, and we're also going to extract the day from the order date, and we're going to extract year from the order date. So this is kind of where you have to extract month, day, and year. and we're going to see how things went by different years to see if there's a trend in the purchasing patterns by the customer. Here's another one. We're actually using a CTE. In this case, our CTE. By the way, if you don't know what a CTE is, it's a way of running a subquery without having to embed the subquery. And the keyword there is with. So we're going to say, we're going to create a value from this query. So ranked is all the output line for this query. We're getting the employee ID, the department salary. And we're going to, once again, partition by department. We're going to order that by salary descending. So the highest paid is first and so on. And then from there, we're going to come through and we're going to look at the ones that have less than or equal to 3. So doing some sort of comparison on the employees with 3 or more employees. Here's one that I was going to intend as a quiz. Let's see how it goes. So we're going to sum sales over the customer ID as total sales from order. And this is also done in a CTE. Great thing about CTEs is they're reusable. So we can call it multiple times. As you can see, we have sales data here. We're not calling multiple times this one, I'm sorry. So in this case, we're going to take the sales divided by total sales, multiply it by 100, so we have a percent. So every sale we can see for each customer, their percentage of what they bought generated from this. Okay, last hint, since I promised you 5, be creative. I know just asking you to be creative is kind of a weird thing. Look for common requested information. Are your accountants looking for quarterly details, weekly, pay period options? Is manufacturing looking for production run numbers? Go out there and take a look at the type of request you have and start writing your window functions around that. So, quick conclusion, window functions provide great insights, better than when you get from a group by. The syntax is complex but manageable. The unbounded stuff can throw you for a little bit, but I hope that you got you over that. Okay, dbeaver, we're a universal database tool. We have a community edition. These here are our 5 enterprise editions. They have AI assistance, so if you have queries that you don't know what they do, you can point it to that. You can actually write queries in English or Spanish, French, Basque, or any other handful languages. We give you a universal interface to your database, so if you're playing in MySQL and you know that what you used to do in Postgres to get the output vertical was a /x, the equivalent in MySQL is a /g. If you don't want to remember that, we're universal interface. We do backups, we can port data. So if you're running, it's like MariaDB and you want to port over to Oracle or vice versa, we can mitigate that for you and help you do that. And with that, once again, the slides are here.